So yes, all these different figures have four sides. So what we want to be able to do is prove that a quadrilateral is a parallelogram. And so we're going to remember our properties of parallelograms. So if a quadrilateral, for example, this figure here, ABCD, is a parallelogram, well, then it must follow the following criteria. The opposite sides, which are parallel to each other, are congruent to each other. So our opposite sides, for example, AB and DC, they must be parallel to each other, so never intersect. And if they do so, and they are also congruent to each other, so for example, this is 8, then this would also be 8. So that's one of the criteria of a parallelogram. The next thing is that opposite sides are congruent. So for example, D's opposite side is B. And let's say we know that D is equal to 70 degrees. Well, then given that we can assume if this is a parallelogram, then B must also be equal to 70 degrees. So it must follow that criteria. And then lastly, that diagonals bisect each other. So for example, let me say that I have a diagonal, a pre-existing diagonal right here. And say that I'm told that the entire length of that diagonal is equal to 10 degrees. I mean 10 units. Well, basically, what this criteria is telling me is that the opposite diagonal or the other diagonal must bisect that existing diagonal into two congruent halves, making, oh my goodness, sorry guys. And by doing so, it cuts A to this to 5 and this to C to 5. So basically diagonals cut each other into half, so they bisect each other, okay? Does anyone have any questions about any of these different properties right now? Any questions? No? And then these are very similar, and these are where we get the different theorems that we saw on Wednesday. So basically, whenever we're trying to prove a quadrilateral as a parallelogram, what we're going to do is use the converse. And the reason we're going to use the converse is because, for example, the parallelogram side theorem started with if a parallelogram then both pairs of opposite sides are congruent. So this is just an example of one of the theorems that we saw on Wednesday. And this theorem was the parallelogram side theorem. Right? And basically what this tells us is that if parallelogram then opposite sides congruent, right? Well, what the converse does is it switches it around. And so the converse of the parallelogram states, if both pairs of opposite sides are congruent, then the quadrilateral is parallelogram. So what it does is it switches the hypothesis and the conclusion, thus creating a statement that will allow us to determine if a quadrilateral is a parallelogram. So basically what the converse is doing is it's telling us we need to work backwards to prove that just the regular figure that we're given here, how can we prove that that's in fact a parallelogram? And so, for example, to prove that this was a parallelogram, then what we would need to know, what our given would need to be, is that our two opposite sides are congruent to each other. And if we know that, well then we can assume that that quadrilateral is in fact a parallelogram. Okay, so our opposite sides are congruent. So again, if this was 8, then this would be 8. If this was 10, then this would be 10. Okay? So basically what we're doing to prove that a quadrilateral is a parallelogram is taking the converse of our original theorems, which we saw on Wednesday. And so here's another example of a converse. The converse of the angle side theorem says if both pairs of opposite angles of a quadrilateral are congruent, well then the quadrilateral is a parallelogram. So say we start with this figure, we don't know any information about this figure. Then say we are given that angle A is congruent to angle C and angle B is congruent to angle D. Well, if that is in fact our given, and if that is in fact true, well then we can assume that ABCD is a parallelogram. And so what does this look like? We'll say that we knew this was equal to 110 and this was equal to 80. Well then its opposite angles would be congruent, so this would also be equal to 80 because that is the opposite angle. And this would be equal to 110. Okay. Next converse we're going to encounter is the converse of the parallelogram diagonal theorem. So if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So say we're just given this information in this diagram. Well, what this diagram is doing is it's showing us some given information. More specifically, it's showing us that AE is congruent to EC and DE is congruent to EB. And we see this in the diagram represented by these symbols right here, right? Those two are congruent to each other. These two are congruent to each other. So what is this saying? Well, it's basically saying that the diagonals bisect our original line segments into two congruent halves. And because it does so, we can assume that this is a parallelogram. And then lastly, we have the single opposite side pair theorem, which we haven't looked at yet. And so this is another way to prove if the quadrilateral is a parallelogram. The single opposite side pair theorem basically says if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So this is basically the same thing as our opposite side pair theorem, but we're looking at the single opposite side pair theorem. And basically what it's saying is if even one side of opposite angles are congruent, then we can prove that that is a parallelogram. It's a parallelogram. Okay, so if all I know is that AB is congruent to DC, then parallelogram. If all I know is that AD and BC are congruent, then that is a parallelogram. So this is the single opposite side pair theorem, which is another way to prove if a quadrilateral is a parallelogram. Okay. So any questions about any of these or what we're even doing? Why we're looking at the converses, what the converses can tell us, what we're even looking for. Any questions? So basically what we're able to do is we use the converse. So we use the converses of our original theorems, our original parallelogram theorems, to prove that a quadrilateral is in fact a parallelogram. Right? Because there's many different types of quadrilaterals, but how can we prove that that quadrilateral is a parallelogram? And so the way we do that is we use the converses and we work backwards. So there are several ways to prove a quadrilateral is a parallelogram. We can use the converse of the parallelogram side theorem, which basically says both pairs of opposite angles are congruent. We can use the converse of the angle side theorem, which tells us that both pairs of opposite sides are congruent. Or the converse of the parallelogram diagonal theorem, which tells us that diagonals bisect each other. Or we can use the new theorem that we looked at today, which is the single opposite theorem, which basically says if even one pair of opposite sides are both parallel congruent, well, then we can prove that that figure or that quadrilateral is in fact a parallelogram. Okay. So today was very much just a review of what we went over Wednesday, but now what we are able to do is we're able to switch the hypothesis and conclusions of our theorems that we saw Wednesday, and by doing so, we're able to prove that a quadrilateral is a parallelogram. Okay. Any questions? We'll go over more examples of this tomorrow, but if there's no other questions, you guys may log off.